Captain Rogers, here are 4 new trainees assigned to your flight. Lieutenant Hopkins, O'Shea, Visconti, and Bolland. Hopkins?
Captain?
O'Shea?
How do you do? Visconti.
Visconti? Bolland?
Yes, sir. Sure is a big ship. Pretty hot to handle, sir?
Oh, I wouldn't say so. She's a mighty sweet airplane.
Comes in like a rocket the way it looks to me.
Oh, she's easier to land than you think.
Aren't there a lot of trick gadgets in this plane?
Well, not much more than you have in training planes. Just a few things you need for high-altitude work. And they put them where they're easy to use. It's got the roomiest cockpit of any fighter plane I've ever seen. Now, it's easy to fly if you just think about what you're doing.
I'll bet there isn't much time to think either.
Well, that's about all there is to do up there, Bolland. This ship flies just like any other airplane. You do about the same things you've always done. Of course, she doesn't fly herself, you know.
Does she feel very heavy in the air, sir? Sir, how fast will she dive? When do you use the turbo?
Well, I think you guys are getting just a little bit ahead of me. Suppose we go into the pilot's room and we'll begin at the beginning. Well, plant yourselves, boys, while I climb out of this stuff. Well, now, if I'm going to help you fellows understand the P-47, the best thing for me to do is to dish out a lot of facts quickly. We can get together for questions whenever you have them. Now, plenty of our boys are moving up into combat zones ahead of their crews. And they're finding out that it comes in mighty handy to know a lot of details about their airplane. And this is the time to find those things out. Now, you should keep in mind that this airplane was built to give us our fastest, deadliest high-altitude fighter.
Sir, you say high altitude. What altitude do you mean?
Around 30,000 feet, between 25 and 35,000. Well, now you're going to be sitting up here behind 2,000 horsepower. That's a lot of power, but it's the best life insurance you can have. This airplane costs about $100,000 bucks, and they say it takes 30,000 man-hours to build it. I think it deserves some respect from pilots. Now, to handle the P-47 the way the Army expects you to, you should know everything possible about it before you take off the first time. You've got real armament and speed. You're not going to have any trouble with it because it's got good flying characteristics all the way. And it's good on landings. As for weight, well, you'll hear all the boys say you're never even conscious of this plane's weight anytime you've got flying speed. Well, now, let me show you how the P-47 is put together. To begin with, this is the biggest single-engine, single-seater in service. Has a wingspan just short of 41 feet. It's a little over 35 feet long. Stands 12 feet 8 inches high and weighs about 7 tons with a full load. The power plant is 2,000 horsepower with a turbo, and it swings a 4-bladed, 12-foot 2-inch Curtiss prop. Well, let's look at this power plant. This is an 18-cylinder Pratt & Whitney radial engine. It's the twin Wasp with 9 cylinders in each bank. Now, one of the first things I noticed about this airplane is that it's a smooth flying ship in every way. She'll pick up a lot faster than planes you've been flying. And your turbo will allow the engine to develop its full 2,000 horsepower at high altitude. You want to learn all about this prop. It's a Curtiss electrically controlled constant speed propeller. Now, the reason there are 4 blades is to have enough propeller area to absorb the power of this 2,000 horsepower engine. Right here, on the left side of the cockpit, is a switch panel with a selector switch that gives you positions for automatic or manual control of the propeller. You've got increase RPM and decrease RPM positions. Ordinarily, you'll use the automatic position, but if that should ever fail while you're flying, switch to manual and then increase or decrease RPM. Of course, you want to check your breaker switch first. Well, now here are your 2 self-sealing gas tanks. The main tank, forward of the cockpit, holds 205 gallons. Your auxiliary tank holds 100 gallons. The plane has better flying characteristics when this auxiliary tank is empty. So after takeoff, when you've reached a safe altitude, you switch to auxiliary and use this gas first to put the plane in better trim. There's a fuel level warning light on your instrument panel to tell you when you're down to 40 gallons in your main tank. Underneath the main and auxiliary tanks are electrically operated booster pumps. They're automatically on when fuel from that tank is being used. If the engine-driven pump fails, you turn your emergency and high-altitude rheostat to increase the speed of the booster pump.
Captain, what's the fuel consumption of the engine?
Well, that depends on your power and speed. For absolute minimum cruise, you'll use anywhere from 60 to 120 gallons an hour. However, at full military power, you'll consume as much as 275 gallons an hour. When the warning light comes on, you've got a maximum of 20 minutes left. Here's your oil tank up here, and down here are your oil coolers with shutters controlled from the cockpit. This is your main air ramp. This is your GE turbo. It's a lot more simple than it looks. The exhaust gases come from the engine, back through these pipes to the turbo. Compressed air leaves the turbo, comes through the cooling system here, back through these pipes to the carburetor, down into the internal compressor to the cylinders. This is the guts of the system. Let's take a look at the real thing over here. This is a cutaway of the turbo. Now up here is where all of the compression takes place. The exhaust gases come in here and spin this bucket wheel. The bucket wheel is on the same shaft as the impeller, and it's this impeller that actually compresses the air. The faster the bucket wheel turns, the faster the impeller rotates, and the more air is compressed and sent to the engine. Here, just off the exhaust manifold, are waste gates. When these gates are wide open, the exhaust gas is dumped out into the air instead of being directed back to the turbo. But the higher you take your airplane, the more these gates will close, which means the exhaust gas goes back in an increasing amount and puts the turbo to work compressing air for the engine. This action is controlled by a supercharger regulator. You guys will learn a lot about controlling your turbo when you're ready for altitude work. The throttle and turbo on the quadrant are normally linked together, but in transitional training you won't be using the turbo. Later on, if you want to get off the ground fast with full military power, you'll set the throttle and turbo control handle all the way forward, getting 52 inches manifold pressure and 2,700 RPM. Using maximum power for more than 5 minutes isn't a very smart idea, unless you happen to get a hiney on your tail. When you throw this switch on top of the throttle and push both throttle and turbo full forward past the throttle stop, you'll get more emergency power through the water injection on the P-47 D5s and subsequent models. When you're using water injection, water is mixed with gas, and you'll really go places. Water injection is available for only 11 minutes continuous use, and you've got to use it sparingly, just like your ammunition. It sounds screwy, but brother, when you need that extra power, water injection will give it to you. Now let me caution you about something. When you're using the turbo and throttle interconnected, they should be retarded slowly. When you're using them individually, always retard the turbo first and then the throttle, making sure the turbo is never left ahead of the throttle. Your landing gear and flaps are operated hydraulically. I'll show you the controls when we get in the cockpit. As for armor, you've got steel plate in front of you about here, bullet-resisting glass, and your engine also gives you protection from the front. In back of you, you've got steel plate about here, and your fuel tanks give you secondary protection from underneath. As for firepower, you've got 8 50-caliber machine guns, 4 in each wing, with a maximum loading of 3,400 rounds. There's a trigger on the stick that fires all your guns at once. And let me tell you, they pour out plenty of hot steel.
How are the guns charged, sir?
Manually, on the ground. Well, I think I've told you about everything you need to know, outside of the fact the little man said there are 105,895 rivets in this airplane, and enough aluminum to build the biggest kitchen sink in the world. Any questions? Okay, Lieutenant, suppose you come out on the line and we'll check through the cockpit. And the rest of you might be looking through the poop sheets. And get some time in that Republic cockpit training.
These flaps are left down to keep them from getting walked on.
Now, nearly everything in here is familiar to you, but let's look at this cockpit clockwise and see what you've got in the 47 that may be new to you. Now, down here on your left is your fuel selector. You take off on main. On the trim box, you've got your elevator crank here. Now, this knob nearest the rudder is for the rudder, and the one toward the front is the aileron tab control. Also, down on your left, you've got this emergency hydraulic hand pump for use if the engine-driven pump fails. And here, your gun heat control. For your flaps, forward and the flaps are up. You pull back to lower them. You can stop your flaps in any position by putting the control in neutral. Well, now then, for your landing gear, to raise the gear, you flip this safety lock, press this button, and raise the handle. And be sure to let it go all the way up. To lower the gear, push the handle all the way down.
Sure is a wide landing gear.
You betcha. And that's a big plus for pilots. Well, now then, up here are your indicators for oil and intercooler shutter. Open for takeoff, neutral for landing. They're electrically operated from the switch panel. Well, now, going on clockwise, this is the gun and camera switch to make sure it's off when you're landing. Turbo, throttle, prop, mixture. When you're starting the engine, you'll keep the mixture control in idle cutoff until the engine is firing. On your switch panel, there's your generator switch, propeller switch, and the rheostat that determines the speed of the booster pumps for your fuel supply. This, of course, stays in starting, except in emergency if the engine-driven pump fails. Here's the landing gear warning light. It's a very important little item. When you push the throttle forward on takeoff, the warning light will come on and will remain on until the wheels have been retracted and are definitely up and locked, at which time the light will go off. It will remain off until your throttle is almost fully retarded, as in coming in for a landing. The light will then come on and stay on until you have lowered your landing gear and it's fully down and locked. You've got standard instruments on your panel. Flight instruments are in the middle. Your engine operating dials are on the right. Notice that the speed limit on this airplane is redlined at 500. Here's your fuel level warning light. Remember that when it comes on, you've got a maximum of 20 minutes left to find a place to sit this baby down. And this is the light for your turbo, which you don't have to worry about for a while, but which works like this. At turbo speeds around 1500 RPM, this light flickers. That tells you the light is in working order. And then it goes off until your turbo reaches about 18,000 RPM. And then it starts to flicker again. When your turbo gets up to 18,250 RPM, the light comes on steady and stays on steady until you reduce turbo speed below critical. The idea in high-altitude flight is to fly with this light flickering. Of course, you won't have to pay any attention to that until you get into altitude work. Now, the instruments on your panel are pretty much standard. Your criticals are shown in red, and you're okay so long as you're in the green. You've got your checklist, against which you can double-check your limits. Here is your parking brake. And here are your oxygen controls. Before you start going on altitude missions, the oxygen officer will give you the details on your oxygen equipment. You'll want to know how to check your oxygen equipment carefully, especially for leaks. You've got a blinker to show when you're receiving oxygen with this demand type system. Here's a supply warning light, and there's your supply gauge. When the time comes, you'll get all the facts, so you'll always know how to use your equipment. Over here is your cowl flap control. Open for starting. You've got some radio equipment over here. It's simple enough, but you'll get the details from your radio officer. Here's your tail wheel lock. With the handle back, the tail wheel is unlocked for taxiing, pushed all the way forward, and it's locked for takeoff and landing. That's your flap equalizer. To check for equal pressure, notice this rod. It should stick out 3/8 of an inch. You can make this check only when the engine is running. Now then, your canopy will slide forward when you press that release latch. Go ahead, try it. When you get it closed, take your finger and feel right under here for this nubbin. If you can feel it, she's locked all right.
This ring. Oh, I see. Emergency exit.
Right. If you want to get the canopy open in a hurry, you pull that ring and press the canopy release at the same time. 2 spoilers on the leading edges of the canopy open, and wind pressure forces the canopy back. Now then, if your canopy ever gets jammed on the ground, you've got these levers on each side. When you push them up, the glass panels fall out.
Well, that looks like about everything. Except there sure is a lot of stuff in that switch panel.
Oh, don't let that bother you. These are all circuit breakers down here, pop-out fuses. These are your light switches. They're all labeled, and you can study them. This is the ammeter. And here's the gun sight light rheostat. Well, what you've got to do now is give yourself plenty of drill in this cockpit. You want to know the importance of every instrument and exactly how and why to use each one of them. So remember, when you've got this 47 up in the air, it's too late to start thinking about what you're going to do. Play around with a cockpit trainer in the pilot's room. It isn't meant to be a substitute for the real thing. It's a training device that'll help you learn the cockpit in your spare time, if any. You're going to know this cockpit blindfolded before you fly the airplane, and time in drilling yourself is the only way you're going to really know it. When you know the Thunderbolt the way you knew your trainers, then she'll really perform for you. And you'll know you've got a real airplane to be fighting in.